Implementation of China's next-generation supersonic jet technology by 2025. Overview. China's aerospace ambitions are reaching new heights with the development of next-generation supersonic jet technology spearheaded by two significant projects, the C-949 jet by Commercial Aircraft Corporation of China Comac and the Quantianhou, also known as Monkey King, by Sichuan Lingkong Tianxing Technology. These projects aim to reintroduce commercial supersonic travel and position China as a formidable competitor in the global aerospace industry. The initiative is backed by a substantial budget of $1.8 billion and is structured into four distinct development phases, each focusing on critical aspects of aerospace innovation. Project details. 1. C-949 jet development. Announcement and specifications. In March 2025, Comac announced the C-949 jet designed to fly at a speed of Mach 1.6. This aircraft will have a range of approximately 11,000 kilometers (6,800 miles) and a seating capacity of 168 passengers. Notably, the C-949 will be much quieter than its predecessor, the Concorde, with sonic booms measured at 89.3 decibels compared to the Concorde's 105 decibels. This reduction in noise pollution addresses past complaints that led to the Concorde's operational limitations. Technological innovations. The C-949 features a reverse-camber fuselage design intended to minimize the sonic boom effect. By altering the airflow around the aircraft, it significantly dampens the shock waves generated during supersonic flight, which previously restricted overland operations due to noise complaints. 2. Quantianhou Monkey King. Prototype development. The Quantianhou, unveiled in January 2025, aims to achieve speeds of Mach 4, effectively doubling the speed of the Concorde. The aircraft is designed to operate in near space at altitudes between 20 and 100 kilometers above Earth's surface, enabling it to cover vast distances rapidly. The maiden flight of this supersonic passenger aircraft is projected for 2030. Technological focus. This aircraft emphasizes the development of advanced aerodynamic designs and high heat-resistant materials, which are crucial for sustaining the intense conditions experienced at such high speeds. The project represents a significant leap in aerospace technology, positioning China to test innovative power systems and material science. Budget and phases. The combined budget of $1.8 billion for both projects will be allocated across four key phases. 1. Research and development, focused on innovative designs and materials. 2. Prototype testing, includes rigorous testing of aerodynamics and systems. 3. Regulatory approval, navigating international aviation regulations to ensure compliance with noise and environmental standards. 4. Commercial rollout, preparing for operational deployment in the market. Global context and competition. China's foray into supersonic aviation comes amid a resurgence of interest in commercial supersonic travel worldwide, with various competitors, particularly in the United States. Companies like Boom Supersonic and Spike Aerospace are also working on supersonic aircraft, emphasizing quieter and more efficient designs. China's entry into this market raises concerns regarding dual-use technology, particularly given Comac's connections to the People's Liberation Army and the ongoing U.S. sanctions against the company. This geopolitical dimension adds complexity to China's ambitions, highlighting the delicate balance between commercial innovation and military applications. Conclusion. China's ambitious plans for the C-949 and Quantianhou projects signify a strategic movement to establish itself as a leader in aerospace innovation. With advanced technology, significant investment, and a competitive international landscape, these initiatives are poised to reshape the future of air travel. The combination of faster speeds, greater capacities, and reduced noise levels aims to revive the commercial supersonic sector, potentially transforming global air travel by 2025 and beyond. The success of these projects will depend on overcoming regulatory challenges and demonstrating technological viability in an increasingly competitive market. The implementation of China's next-generation supersonic jet technology, particularly through the development of the C-949 jet and the Quantianhou Monkey King, is marked by several counterintuitive aspects that challenge common perceptions about supersonic flight and technological development. Here are some key counterintuitive points identified within the content. 1. Lower speed yet greater capacity. While the C-949 jet is designed to fly at a maximum speed of Mach 1.6, which is slower than the Concorde's Mach 2.2, it boasts a higher passenger capacity of 168 compared to Concorde's 128. This suggests that the focus may be shifting from sheer speed to accommodating more passengers, which could redefine market expectations for supersonic travel. 2. Quieter operations. Despite supersonic speeds, the C-949's design incorporates a reverse-camber fuselage to significantly reduce sonic boom noise 89.3 decibels compared to the Concorde 105 decibels. This implies that advancements in aerodynamic design can potentially overcome historical criticisms of noise pollution associated with supersonic flights, which could lead to a more favorable regulatory environment for overland flights. 3. Near-space operations for passenger aircraft. The Quantianhou is set to operate at altitudes between 20 to 100 kilometers, which is traditionally associated with high-altitude military operations or space vehicles rather than commercial passenger aircraft. This approach challenges the conventional understanding of commercial air travel and raises questions about air traffic management and safety regulations at such altitudes. 4. Dual-use technology concerns. The advancements in aerospace technology, particularly the rapid development of supersonic jets, raise concerns about the dual-use nature of such technology for military applications. While this is a common concern in aerospace development, the specific focus on supersonic capabilities for both passenger and potential military use demonstrates an unexpected intersection of commercial ambition and defense strategy. 5. A significant investment with global competition. The $1.8 billion budget for these projects may seem substantial, yet it is relatively modest considering the vast investments made by competitors in the US and elsewhere. Companies like Boom Supersonic and Spike Aerospace have been backed by extensive funding and successful test flights. China's entry into this market reflects a strategic gamble on rapid technological advancement that could disrupt established competitors despite its seemingly lower initial speed offerings. 6. Innovations in materials science. The focus on high heat-resistant materials and advanced aerodynamics for the Quantianhou indicates a shift towards leveraging cutting-edge materials science in aerospace design. This may counter the perception that traditional aerospace materials and designs are sufficient for supersonic travel, highlighting a potential revolution in the materials used in aviation. 7. Regulatory challenges as opportunities. Although regulatory hurdles regarding environmental impact and noise pollution are often seen as barriers to entry for supersonic travel, the innovative designs employed by the C-949 and Quantianhou may present opportunities to reshape those regulations. If these aircraft can prove to be quieter and more environmentally friendly, it could lead to a re-evaluation of the restrictions currently placed on supersonic flights. 8. Competitive landscape. The global landscape suggests that China's entry into supersonic travel is not solely about catching up but potentially challenging established powers, including the US. This reflects a broader trend where nations are investing in aerospace technology not just for commercial gain but also as a statement of technological prowess and national pride. In summary, the developments surrounding China's supersonic jet technology reveal a complex interplay of speed, capacity, noise reduction, and regulatory challenges that contradict traditional assumptions about what defines success in the aerospace sector. The strategic choices made by Chinese aerospace companies highlight a nuanced understanding of the evolving market dynamics and technological possibilities in supersonic travel. In the report on China's next-generation supersonic jet technology, several important details may be overlooked that carry significant implications for both the aerospace industry and international relations. Here are the key overlooked aspects and their significance. 1. Dual-use technology concerns. One of the most pressing points that may be overshadowed is the dual-use nature of the technology being developed for the C-949 and Quantianhou projects. Given Comac's ties to the People's Liberation Army (PLA) and the ongoing sanctions imposed by the U.S. government, there is a growing concern that advancements in supersonic technology could have military applications. This dual-use potential raises alarms about not only the implications for commercial aviation but also for global security dynamics. Significance: the potential military applications of supersonic technology could lead to an arms race in aerospace capabilities. Countries may feel compelled to enhance their own military aviation technologies in response to China's advancements, thus escalating geopolitical tensions. Furthermore, the ability to rapidly deploy military assets over long distances at supersonic speeds could shift power balances in regional conflicts. 2. Advanced aerodynamic innovations. The report briefly mentions the reverse-camber fuselage design utilized in the C-949 jet, which is a significant aerodynamic innovation aimed at reducing sonic booms. While this detail is included, the broader implications of such innovations are often overlooked. This technology not only addresses past complaints about noise pollution but also represents a critical step in the evolution of aerodynamics for high-speed aircraft. Significance: the advancements in aerodynamics could set new standards for not only commercial aviation but also influence military aircraft designs. If successful, these innovations could lead to quieter, more efficient jets that redefine the operational parameters for air travel, making overland supersonic flights feasible again. This would mark a paradigm shift in how air travel is perceived and regulated globally. 3. Regulatory challenges and environmental impact. The report mentions potential regulatory hurdles regarding noise and environmental impact but does not delve deeply into the complexities of achieving regulatory approval. The historical context of the Concorde's operational limitations due to noise regulations illustrates the potential roadblocks that the C-949 and Quantianhou projects might face. Significance: as international discourse increasingly focuses on sustainability and environmental responsibility, any new aircraft technology will need to align with stringent regulations. The ability to gain regulatory approval in various aviation markets, especially in Europe and North America, could determine the commercial viability of these projects. Failure to address these concerns adequately could result in significant delays or modifications to design and operational plans. 4. Financial investment versus market viability. The reported budget of $1.8 billion for both aircraft projects is substantial, yet the long-term market viability of supersonic travel remains uncertain. Despite the technological advancements, the commercial success of such aircraft will depend on market acceptance, pricing, and competition from existing air travel options. Significance: investors and stakeholders may overlook the fact that even with advanced technology, the demand for supersonic travel must be clearly established. If market conditions do not align with production and operational costs, the financial investment could lead to losses rather than profits. This aspect is crucial for understanding the sustainability of the aerospace initiatives being pursued. 5. Global competition and collaboration dynamics. While the report highlights competition from US-based firms like Boom Supersonic and Spike Aerospace, it misses the broader implications of this competition on global collaboration in aerospace technology. The international race to develop supersonic jets could also foster opportunities for collaboration in research and technology sharing. Significance: the competitive landscape could lead to fragmented markets and increased nationalism in aerospace development. Conversely, it might also encourage partnerships between nations or corporations to pool resources and knowledge. This could either enhance technological advancements or lead to a divide where countries hoard technological innovations for strategic advantages. 6. Cultural and economic factors in aviation revival. The narrative surrounding the revival of supersonic travel often omits the cultural and economic factors that might influence public acceptance. The historical legacy of the Concorde, marred by its operational challenges and the catastrophic incident in 2000, presents a psychological barrier that new supersonic projects must overcome. Significance: understanding public sentiment towards supersonic travel shaped by historical events and contemporary environmental concerns is crucial for successful marketing and operational strategies. Engaging with the public and addressing concerns about safety, noise, and environmental impact will be essential for the acceptance of these new aircraft. Conclusion: the development of China's next-generation supersonic jets represents a significant leap in aerospace technology. But the implications extend far beyond engineering. The dual-use nature of the technology, regulatory challenges, market viability, and the dynamics of global competition and collaboration are critical factors that will shape the future landscape of aviation. By recognizing these overlooked points, stakeholders can better understand the complexities involved in bringing these ambitious projects to fruition and the broader impact they may have on international relations and the aerospace industry as a whole. 1. Technological innovations in aerodynamics and noise reduction. One of the most valuable aspects of China's next-generation supersonic jet projects, particularly the C949 and Quantianhou, is the significant technological advancements aimed at reducing sonic boom noise and enhancing aerodynamic efficiency. The C949 employs a reverse-camber fuselage design that minimizes noise pollution compared to the Concorde. This is crucial for addressing public concerns about noise which previously hindered supersonic travel. Additionally, the Quantianhou is focusing on high-speed capabilities with innovative materials and power systems designed for operation in near space. An in-depth discussion can explore how these advancements in aerodynamics and materials science could reshape the future of aviation and how they compare to ongoing international efforts in the same field. 2. Strategic budget allocation and development phases. With a projected budget of $1.8 billion, the structured approach to developing these supersonic jets through 4 distinct phases: research and development, prototype testing, regulatory approval, and commercial rollout, highlights the strategic planning behind these ambitious projects. An analysis of these phases can provide insights into project management in aerospace, the importance of iterative testing and regulatory compliance, and the financial implications of large-scale aerospace initiatives. Discussing how budget allocation impacts technological development and market readiness can reveal broader lessons applicable to other sectors within the aerospace industry. 3. Global competition and implications for the aerospace industry. China's entry into the supersonic race introduces significant competition for established players like Boom Supersonic and Spike Aerospace, which are also developing next-generation supersonic aircraft. An in-depth analysis could focus on the implications of this competition for global aerospace dynamics, including potential shifts in market leadership, innovation speed, and international collaboration or tensions. Moreover, the dual-use nature of the technology, where advancements in civilian aviation may also have military applications, raises concerns in international relations, particularly regarding the US-China technological rivalry. This discussion could delve into how geopolitical factors influence aerospace innovation and competition. 4. Regulatory challenges and environmental concerns. As China moves forward with its supersonic initiatives, it must navigate complex international regulations concerning noise and environmental impact similar to the challenges faced by the Concorde. An exploration of these regulatory landscapes can provide insights into how environmental considerations shape technological advancements in aviation. Discussions could include the potential hurdles for regulatory approval that the C949 and Quantianhou may face, the historical context of supersonic travel regulations, and the balance between innovation and environmental stewardship in the aerospace sector. This analysis can also reflect on how companies can proactively address regulatory challenges through technology and design innovations. 1. The Concorde. 1969 to 2003. The Concorde was a turbojet-powered supersonic passenger airliner developed jointly by British Aircraft Corporation and Aerospace. It entered service in 1976 and was known for its ability to cruise at speeds of Mach 2.0 for approximately 1,354 miles per hour. The Concorde significantly reduced flight times, allowing, for example, a flight from New York to London to be completed in under 3 hours. However, its operations were hampered by high operational costs, limited routes, and concerns over noise pollution, particularly due to its sonic boom. The Concorde was retired in 2003 after a tragic crash in 2000 and the subsequent decline in passenger numbers following the September 11 attacks. 2. Boeing SST supersonic transport. In the 1960s, Boeing initiated the development of its own supersonic transport aircraft, the Boeing 2707. This project aimed to create a commercial jet capable of flying at speeds of Mach 2.7. The design featured innovative technologies including a variable sweep wing for improved aerodynamic efficiency. However, the Boeing SST faced numerous challenges including rising costs, environmental concerns, specifically noise regulations, and competition from the Concorde. The project was ultimately cancelled in 1971 due to these escalating issues and the changing landscape of commercial aviation. 3. Lockheed Martin's Quiet Supersonic Travel KSST. In 2018, NASA selected Lockheed Martin to develop a prototype of a quiet supersonic aircraft under its X-plane program. The design focused on creating a supersonic jet that could travel at speeds of up to Mach 1.4 while producing significantly lower noise levels, a sonic boom of no more than 75 decibels, which is roughly equivalent to the noise of a car door slamming. The KSST aims to demonstrate the feasibility of quiet supersonic flight and is part of a broader effort to revive interest in supersonic travel while addressing the environmental and regulatory challenges that previously hindered its commercial viability. The first flights of the KSST are expected to commence in the coming years. China's ambitious plans for next-generation supersonic jet technology are set to reshape the aerospace landscape by 2025, featuring 2 key projects: the C-949 jet by Comac and the Quantianhou Monkey King by Sichuan Lingkong Tianxing Technology. With a combined budget of $1.8 billion structured in 4 phases, these initiatives reflect China's determination to compete on a global stage in commercial supersonic travel. Project phases and predictions. 1. Phase 1, Research and Development 2025 to 2026. The projects will commence with intensive research and development efforts focused on aerodynamics, materials science, and noise reduction technologies. The C-949 jet is expected to utilize a reverse-camber fuselage designed to minimize sonic booms, while the Quantianhou will test advanced aerodynamics for speeds up to Mach 4. By mid-2026, prototypes of both aircraft should be nearing completion, with preliminary tests scheduled shortly thereafter. 2. Phase 2, Prototype Testing 2027 to 2028. Following successful R&D, prototype testing will begin. The C-949 aims for its first test flights by late 2027, while the Quantianhou is anticipated to fly by 2030. The focus during this phase will be on performance evaluation, safety assessments, and the gathering of regulatory feedback. The successful completion of these tests will be pivotal as they will shape further development and regulatory strategy. 3. Phase 3, Regulatory Approval and Refinement 2029 to 2030. Achieving regulatory approval will be a significant challenge, particularly regarding noise and environmental impact. The C-949, designed to produce quieter sonic booms, may face less resistance, but the Quantianhou's Mach 4 capabilities might trigger stricter scrutiny. By late 2030, both aircraft should be positioned for commercialization, provided that they meet international aviation standards. 4. Phase 4, Commercial Rollout 2031 and beyond. If regulatory hurdles are overcome, commercial operations for the C-949 could commence as early as 2031. The Quantianhou, given its more advanced technology, might see a staggered rollout depending on the success of early tests and public acceptance. The entry of these aircraft into the market could significantly reduce travel times, allowing for non-stop flights over long distances. effectively revitalizing the concept of supersonic travel. Technological innovations and competitive landscape. China's focus on advanced aerodynamic designs and high heat-resistant materials reflects a broader global trend in aerospace innovation. The C949's quieter operation compared to the Concorde and the Quantianhou's unprecedented speed capabilities position China as a formidable contender against American companies like Boom Supersonic and Spike Aerospace. Both competitors are also developing supersonic aircraft, with Boom's XB-1 already in flight testing. The potential dual use of this technology for military applications raises international concerns, particularly in light of the existing U.S. sanctions against Comac. The geopolitical implications of these advancements will likely influence international partnerships and collaborations in aerospace technology. Environmental impact and regulatory challenges. Environmental concerns will play a crucial role in the future of supersonic aviation. The industry must navigate stringent regulations regarding noise pollution and emissions. The C949's design to minimize sonic booms suggests a proactive approach to these challenges, but the Quantianhou's Mach 4 operations may provoke more significant environmental scrutiny. Future outlook. By 2025, China is poised to make significant contributions to the revival of commercial supersonic travel. The successful implementation of the C949 and Quantianhou projects will depend on overcoming technological, regulatory, and environmental hurdles. If these projects succeed, they could redefine air travel, offering rapid intercontinental flights and stimulating international tourism and business travel. 1. Economic impacts. The introduction of these aircraft could create new markets in aviation, spurring economic growth and job creation within the aerospace sector. 2. Global connectivity. With faster travel times, global connectivity will increase, allowing for enhanced business opportunities and cultural exchange. 3. Technological leadership. A successful rollout of these supersonic jets could establish China as a leader in aerospace technology, influencing global standards and practices in aviation. 4. Sustainability and innovation. The industry's focus on quieter, more efficient aircraft could drive further innovations in sustainable aviation technologies, pushing the entire industry toward greener practices. In conclusion, China's investment in next-generation supersonic jet technology is poised to have a profound impact on the future of aviation. The success of the C949 and Quantianhou projects will hinge on technological advancements, regulatory navigation, and market acceptance, setting the stage for a new era in air travel by 2031 and beyond.